In this video I want to talk about the activation of acetyl-CoA to Malonyl-CoA. So basically, if you recall from beta oxidation, we had to activate a fatty acid to acetyl-CoA, which is the activated form of the fatty acid that could actually undergo the reactions of beta oxidation. Similar idea here. With fatty acid synthesis, we have to activate these acetyl-CoAs to their active form, which is Malonyl-CoA. So this is the activated form of acetyl-CoA, and it's the molecule that actually undergoes the reactions of fatty acid synthesis. So we start off with this 2-carbon acetyl-CoA, and we attach this carboxyl group here at the bottom, and that carboxyl group comes from a bicarbonate. And so because this is a carboxylation reaction, it requires biotin. And in fact, the name of the enzyme that catalyzes this reaction is acetyl-CoA carboxylase, because of course, like I said, it's a carboxylation reaction, and that's why it requires biotin. And adding a carbon dioxide group, or essentially the bicarbonate, requires energy. And this makes sense too, given that if we're getting ourselves ready for fatty acid synthesis, it makes sense that we're investing ATP because we're storing energy, so the energy is available. Okay, cool. So this Malonyl-CoA is the molecule that is committed to fatty acid synthesis. So since it's committed, this step here is the first committed step of fatty acid synthesis. And because of that, it is a key regulatory enzyme in fatty acid synthesis. So we'll see more about that later. Now, Malonyl-CoA is going to be the main 2-carbon donor in fatty acid synthesis. And what I mean by that is that earlier we mentioned that when we're building a fatty acid, we're going to continually add 2 carbon units at a time. The molecule that's going to be donating those 2 carbons at a time is Malonyl-CoA. It's kind of weird though, right? Because this is a 3-carbon molecule. Why would a 3-carbon molecule be the 2-carbon donor? And the reason why is that first step, that first reaction, that condensation reaction, actually releases this carbon dioxide. So this 3rd carbon is irrelevant in terms of the product that's yielded. So the Malonyl-CoA is going to be the main 2-carbon donor. And the reason why I say the main 2-carbon donor is because it's going to contribute almost all the carbons to the palmitate that we're going to be making. So of the 16 carbons in palmitate, 14 of those carbons are from Malonyl-CoA. The other 2 carbons are from acetyl-CoA. And that's because the first reaction, the first condensation reaction, brings an acetyl-CoA and a Malonyl-CoA together. After that, every single 2-carbon donor is a Malonyl-CoA. So I hope that video was helpful. Thank you for watching.